Now, is there life on Mars? It's a question scientists have pondered for years.
Mars, the red planet, next door to us.
Mars could be hospitable if it has enough oxygen.
In the effort to live on Mars, one big problem is not having enough breathable air. But now, thanks to a smart computer program, scientists have figured out a new way to make oxygen on the red planet. This amazing discovery could change how we explore and live on Mars in the future. Now, we all know that if we're ever going to set foot on Mars, we need a magic ingredient: oxygen. Sure, we could haul tanks of it all the way from Earth, but what if I told you that there's a team of scientists in China working on a way to make oxygen right there on Mars? Cue the AI chemist superhero. This robot, powered by artificial intelligence, is about to become our planetary oxygen supplier. Picture this: a sleek machine the size of a refrigerator equipped with a futuristic robotic arm. What's it doing? Analyzing meteorites from Mars, of course. Because, let's face it, if you're planning a trip to Mars, you've got to work with what's already there. But why meteorites, you ask? Well, these space rocks are like the red planet's own recipe book. The team, led by the brilliant Jun Jiang from the University of Science and Technology in China, used these Martian meteorites to create catalysts. And what are catalysts, you wonder? They're like the chefs of the chemistry world, making the magic happen by breaking down water into oxygen and hydrogen molecules. Imagine this: Mars, a planet with a thin atmosphere and only traces of oxygen, but hidden treasures of water ice. Our robot chemist, armed with AI wizardry, calculated over 3.7 million possible molecules from 6 different metallic elements in these Martian rocks. That's right, it's like turning Mars into its own oxygen factory. Now, why is this such a big deal? Well, future Mars missions need oxygen not just for astronauts to breathe, but also as fuel for their rockets. And guess what? The key to making these missions cost-effective is using what Mars has to offer. Imagine the savings. No need to drag oxygen tanks across the cosmos. We're getting resourceful up in here. Let's get a bit technical. These catalysts, created by our AI chemist, are the real MVPs. They kickstart chemical reactions that split water molecules, generating precious oxygen and hydrogen gas. It's like turning Martian ice into a goldmine of resources, and it's all thanks to our AI-powered chemist sidekick. And what do the experts think? Andy Cooper, a chemist from the University of Liverpool, gets it. He says, if you think about the challenge of going to Mars, you have to work with local materials, so I can see the logic behind it. AI-powered robot chemist. Yeah, you heard it right, a robot chemist. This futuristic genius isn't mixing potions in a Hogwarts dungeon. It's analyzing Martian meteorites to find the magic ingredient, a catalyst. This catalyst is the key to triggering a chemical reaction that produces oxygen. And where's this all happening? On the red planet itself. Our robot chemist buddy kicks things off by using an acid and chemical mix to dive deep into 5 meteorites. These space rocks either hitchhiked from Mars or have a composition similar to the Martian surface. Armed with lasers and some serious brain power, our robot detects a cosmic cocktail of iron, nickel, calcium, magnesium, aluminum, and manganese in these rocks. Now pay attention, because this is where the magic happens. An algorithm like the AI wizard it is sifts through these elements and figures out that it can whip up over 3.7 million molecules that can break down water and release oxygen on Mars. Talk about turning rocks into life-saving elixirs. And the best part, the chosen catalyst can handle the chill, operating at a cool -37 degrees Celsius, just like Martian weather. But here's the real kicker. This whole process, from analyzing meteorites to picking the perfect catalyst, takes our robot chemist a mere 6 weeks. And if a human researcher tried this, it would take them a whopping 2,000 years. That's right, folks. The future is here, and it's faster than ever. Now let's get a bit sentimental. Jun Jiang, co-senior author of the study and a scientist at the University of Science and Technology of China, confessed, "When I was a boy, I dreamed of interstellar exploration. And guess what? Thanks to our robot chemist, his dream might just come true." Picture this: oxygen being produced on Mars and scientists like Jiang contemplating the possibility of living on the red planet. It's like sci-fi, but better because it's happening right now. But hold your space horses. The scientists want to take this even further. They're putting their AI chemist to the test, checking if it can handle more than just the Martian temperature. They're curious if it can survive the wild differences in atmospheric composition, air density, humidity, gravity, and whatnot. After all, Mars isn't your everyday backyard. It's a whole new world. And guess where you can dive into all the nitty-gritty details of this mind-blowing discovery? The scientists spilled the interplanetary beans in the journal Nature Synthesis, and you can catch all the excitement there. Scientists in China have cooked up a game-changing robot chemist driven by the power of artificial intelligence. This little marvel might just hold the key to extracting oxygen from water on Mars. Imagine that, breathing on Mars without dragging oxygen tanks from Earth. Now that's what I call a space-age upgrade. Andy Cooper, a savvy chemist from the University of Liverpool, breaks it down for us. If you think about the challenge of going to Mars, you have to work with local materials. That makes sense, right? Enter Jun Jiang and his dream team from the University of Science and Technology of China in Hefei. These pioneers led a study, and their findings were published in the scientific heavyweight Nature Synthesis. Now let's get down to the nitty-gritty. Picture this: a mobile machine the size of your fridge, armed with a robotic arm, digging into Martian mysteries. Jiang and his crew aimed to answer a vital question: can this machine create useful catalysts from Martian material? And not just any catalysts, but the kind that can break down water, unleashing precious oxygen. Here's where the real magic happens. The AI-powered system does its thing, using a dash of acid and alkali to dissolve and separate Martian material. Like a cosmic chef, it whips up compounds that become the building blocks for over 3.7 million chemical formulae. And get this, it does it faster than you can say rocket launch. A process that would take a human researcher 2,000 years. Our robot chemist nails it in a fraction of the time. The grand finale: an oxygen evolution reaction catalyst. Translation: a magic potion that can release oxygen from water. Picture this catalyst as your personal oxygen wizard on Mars, making it rain oxygen. And the best part? It's made from Martian materials. No need to haul catalysts from Earth. Our robot chemist is self-sufficient. Now let's talk numbers. Jiang spills the beans. For every square meter of Martian material, this system could churn out nearly 60 grams of oxygen per hour. Imagine the possibilities. Astronauts on future Mars missions could breathe easy, literally, without lugging oxygen all the way from home. And the cherry on top, this robot can keep working tirelessly for years. Talk about a dependable coworker. Now we've got Michael Hecht from MIT's Haystack Observatory saying, "Hold on, folks, there's an easier way to whip up some oxygen on Mars." He's the brain behind MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, chilling on NASA's Perseverance rover that landed on Mars in February 2021. And guess what? MOXIE has been flexing its Martian muscles, successfully pulling oxygen straight out of the Martian air, which is mostly carbon dioxide. Sure, MOXIE is currently like a tiny Martian oxygen chef, only cooking up a few grams at a time due to Perseverance's power limitations. But hold on to your helmets, because the game plan is to scale this bad boy up. We're talking about a MOXIE that could churn out more oxygen than a human settlement could dream of. And that's not all. It could even be the ticket for a rocket's return trip to Earth, providing the fuel it needs. Michael Hecht spills the tea, saying you can produce 2 to 3 kilograms an hour. Now, that's some serious oxygen production. But here's where it gets even juicier. Enter our AI-powered robot chemist, the unsung hero of Martian chemistry. Jun Jiang, the mastermind behind this futuristic chemist, points out that it's not just about oxygen. Oh no, this robot can be the ultimate multitasker on Mars, whipping up other catalysts for things like fertilizing plants. Picture this, a robot chemist creating a green oasis on the red planet. Talk about turning Mars into a botanical wonderland. And the excitement doesn't stop at Mars. Jiang hints at the moon, saying maybe lunar soil is another direction. Our robot chemist could be the interplanetary handyman, creating useful materials wherever humanity decides to venture. Thanks for tuning in. Don't forget to hit that like button and subscribe for more cosmic adventures.